Hi, today we're going to give you a quick overview of the Flockport Self-Service Cloud Platform. The Flockport Self-Service Cloud Platform is designed for sovereign and emerging cloud providers and any platform that needs to give their end users the same flexibility and ease of use that they've come to expect from the public cloud. For this demo, we're going to create a vSubnet. This is similar to VPC in AWS and deploy resources in the new vSubnet, and also give an overview of service discovery, RDS, load balancers, KMS, the App Store, and other app-level services. The UI on the left also gives you access to infra, apps, and cloud. Today we're going to take a closer look at the cloud panel. The cloud panel gives you access to vInstances, vSubnets, C-instances, RDS, load balancers, service discovery, the App Store, KMS, centralized logging, the app scheduler, and user management. vInstances let you deploy instances to your cluster. Click on the Create button to create an instance. Select the instance size, the OS, the vSubnet, and SSH key if needed. You can list vSubnets from the vInstances menu and create keys from the Keys menu. For this demo, we'll create a vSubnet and launch a vInstance and C-instance in the newly created vSubnet. To create a vSubnet, click on the vSubnet panel. This will give you access to the vSubnets menu. Click on List vSubnets to list all available vSubnets. To create a new vSubnet, click on the Create vSubnet button. Enter the subnet or CIDR range. We'll use 10.10.5.0/24 for our vSubnet range. Enter a domain. You can leave this blank and a domain name will be automatically generated. Click on NAT gateway if you want instances in the vSubnet to have outward internet access. We will enable it for this demo. Once you click on Create, a new vSubnet will be created. As we can see, our vSubnet was successfully created. Clicking on List vSubnets will show our newly created vSubnet. Now we can launch vInstances in our new vSubnet. Let's select the instance size, the OS, the new vSubnet we created, and an SSH key. Let's quickly generate an SSH key pair for this demo so we can log into our vInstance. Click on the Keys menu and click on Add Key. Enter a key name. We'll use MyKey5 as our key name. Once you click on Add, a new key pair will be generated and the private key will be available for download. Make sure you copy it as this will only be available once. Now we can use MyKey5 to log into the instance. So let's return to the vInstance menu and create an instance. Once we click on Create, a new vInstance will be created and deployed in our vSubnet. This will take a few minutes. As we can see, the new vInstance was successfully created. The vInstance name is auto-generated. List will show us details on our new vInstance. We can see the vInstance has been deployed to our new vSubnet. Clicking on PS will give us runtime data. We can see our new vInstance is running but has not yet got an IP. We'll click on PS again and now we can see the vInstance has got an IP and it's in the IP range of our new vSubnet. Let us try to log into a new vInstance. We'll use the MyKey5 key we created earlier to log in. As we can see, the key was successfully injected into the new vInstance and we can log in with our new key. We'll run the ifconfig command to see its IP address. You can create multiple vSubnets and launch resources in them. You can create and attach vDisks to instances and make snapshots of instances. C-instances are container versions of vInstances. For this demo, let's launch a C-instance in our new vSubnet. Select the instance size, the OS, and for vSubnet, we'll use the vSubnet we created earlier. Once we click on Create, the C-instance will be created in our vSubnet. As we can see, the C-instance was successfully created. The name is auto-generated. Clicking on List will show us details on C-instances. We can see the C-instance was created in our new vSubnet and is running but has not yet got its IP. We'll give it a few seconds. The C-instance has now got its IP and it's in the vSubnet range we created. You can create snapshots of C-instances in the C-snaps menu and create and attach volumes to C-instances in the volumes menu. The Cloud panel also gives you access to replicated databases. Flockport currently supports replicated MySQL, PostgreSQL, Galera, Cassandra, and Elastic databases. List clusters will list all deployed database clusters. We've made it really simple to deploy multiple replicated databases and scale them. The load balancer menu lets you deploy load balancers. You can deploy Nginx or HA proxy load balancers and add and delete backends to the load balancers. The service discovery menu gives you access to service discovery. You can list endpoints and add and delete endpoints here, and manage and extend service discovery endpoints. You can also list services and checks here. Once an endpoint is deployed, it becomes available for containers and VMs to publish the services to the available endpoint. So this way you get automated service discovery across your cluster. You can add services to containers and VMs and deploy endpoints, and all the services will be published to the endpoint and be discoverable across the cluster. The web server menu lets you deploy web servers or ingress controllers. You can publish container-based apps across the cluster to the web servers so that they can be accessed. The App Store lets you deploy apps cluster-wide. You can click on the categories of apps and select an app and enter a server name to deploy to that server. All apps are signed and downloaded securely. The KMS menu lets you create encryption key pairs and generate encryption and decryption keys. You can create a key by clicking on the Create Key menu. Enter key name and email ID. Once the key is created successfully, you'll see it in the List Keys menu. You can generate encryption keys from the Keys menu. Enter the key name and you'll get a data key and an encryption key pair. You can now encrypt data with the data key and use the eData key to generate the data key back. You can also directly encrypt and decrypt data cluster-wide from the KMS menu. You also get access to a secrets manager that can be accessed both from the UI and from the API. Log servers let you deploy centralized logging. You can deploy multiple log servers to consolidate your logs across your applications, containers, and hosts cluster-wide. We use Elasticsearch and Kibana, so you can consolidate your logs directly from the UI and then access them in Kibana for analytics, alerting, and auditing. The scheduler lets you deploy applications with auto-healing and auto-recovery. List jobs will list all deployed jobs. To add a job, click on Add Job and enter the container name, the count, the server group, and any service to be associated with the container, or any load balancer to be associated with the jobs. Once you click on Add, the job will be intelligently deployed by the scheduler in your chosen server group. You can scale deployed jobs up and down. If an instance goes down, the scheduler will automatically detect it and replace it with a healthy instance. In case the server goes down, the job will be redeployed to a healthy server. This is all automated. We have more detailed demos of the scheduler with auto-healing and auto-recovery in action, so do look out for those demos. Flockport gives you fine-grained user access control. You can create users by role and limit access by resources, so different users will get a different view of the UI depending on their privilege level. You can also limit access by IP and server group. You can also generate temporary time-bound access tokens, so there's a lot of flexibility on offer. The self-service cloud platform brings together infrastructure flexibility and rich application services to give sovereign and emerging cloud providers an automation platform to deliver next-generation cloud services. We have detailed demos on some of the functionality covered here at flockport.com. Please do have a look at them. Thank you for watching.